The Sun, the heartbeat of our solar system. Introduction. Welcome to our educational program about the Sun and its vital role in our solar system. Today, we're embarking on an exciting journey to uncover the secrets of this magnificent star and understand how it influences everything in our cosmic neighborhood. Segment 1. What is the Sun? The Sun is a star at the center of our solar system. It's a colossal ball of glowing gas, primarily composed of hydrogen and helium. Through the incredible process of nuclear fusion, the Sun produces an immense amount of energy that powers not just our days, but the entire solar system. Segment 2. The structure of the Sun. The Sun consists of several layers, each playing a crucial role in its function. Core. At the heart of the Sun, temperatures soar to about 15 million degrees Celsius, 27 million degrees Fahrenheit. Here, nuclear fusion occurs, where hydrogen atoms collide and fuse to form helium, releasing vast amounts of energy. Radiative zone. Outside the core lies the radiative zone, where energy moves outward through the absorption and re-emission of photons. This process can take millions of years, as photons are continuously absorbed and re-emitted in a chaotic journey to the surface. Convective zone. In the convective zone, energy is transported by convection currents. Hot plasma rises towards the surface, cools as it loses energy, and then sinks back down to be reheated. This process creates a churning, boiling effect that we can observe on the Sun's surface. Photosphere. The photosphere is the visible surface of the Sun, where temperatures reach about 5,500 degrees Celsius, 9,932 degrees Fahrenheit. This is the layer we see as sunlight, with a granular appearance due to the convective currents below. Chromosphere. Above the photosphere is the chromosphere, a layer of the Sun's atmosphere where temperatures rise and interesting phenomena such as spicules and filaments occur. Corona. The outermost layer is the corona, which extends millions of kilometers into space and is surprisingly hotter than the Sun's surface, with temperatures reaching up to 2 million degrees Celsius, 3.6 million degrees Fahrenheit. The corona is visible during a total solar eclipse as a white halo around the Sun. Segment 3. How the Sun produces energy. At the Sun's core, nuclear fusion combines hydrogen atoms to form helium, releasing a tremendous amount of energy. This energy, in the form of light and heat, travels outward through the radiative and convective zones before reaching the photosphere and escaping into space as sunlight. This light takes about 8 minutes to travel from the Sun to Earth, providing the essential energy needed for life. Segment 4. The Sun's influence on the solar system. The Sun's gravity holds the solar system together, maintaining the orbits of planets, moons, asteroids, and comets. Its energy drives weather patterns, ocean currents, and photosynthesis on Earth, making it crucial for life. The solar wind, a stream of charged particles released by the Sun, interacts with Earth's magnetosphere, creating beautiful auroras near the poles and influencing space weather. Segment 5. Solar phenomena. The Sun is a dynamic star with many interesting phenomena. Sunspots. These are cooler, darker regions on the Sun's surface caused by intense magnetic activity. Sunspots can be larger than Earth and are often associated with solar flares and other magnetic disturbances. Solar flares. Sudden bursts of energy from the Sun's surface. Solar flares can release as much energy as billions of nuclear bombs. They can affect satellite communications and power grids on Earth. Coronal mass ejections, CMEs. CMEs are massive bubbles of solar material that are ejected into space. When they interact with Earth's magnetosphere, they can cause geomagnetic storms, leading to disruptions in communication and navigation systems. Solar wind. The continuous flow of charged particles from the Sun's corona. The solar wind shapes the space environment and influences planetary magnetospheres. Segment 6. The Sun and Earth. The Sun's energy is crucial for sustaining life on Earth. It drives photosynthesis in plants, which produce oxygen and serve as the base of the food chain. The Sun also influences weather patterns and ocean currents, playing a pivotal role in our planet's climate system. Without the Sun's energy, Earth would be a frozen, lifeless rock. Segment 7. The Sun's life cycle. The Sun is about 4.6 billion years old and is currently in the main sequence phase of its life, steadily burning hydrogen into helium. In about 5 billion years, it will exhaust its hydrogen fuel and expand into a red giant, engulfing the inner planets, including Earth. Eventually, it will shed its outer layers and shrink into a white dwarf, slowly cooling over billions of years. Conclusion. The Sun is the heartbeat of our solar system, providing the energy and gravitational force that sustain life on Earth and keep our cosmic family together. By understanding the Sun and its many roles, we gain a greater appreciation for the star that makes life possible. Closing remarks. Thank you for joining us on this illuminating journey. Remember, every time you look up at the sky, you're witnessing the incredible power of the sun in action. Keep exploring, and stay curious. Here are some intriguing facts about our stellar neighbor. Massive star. The Sun contains 99.86% of the total mass of the solar system. Its gravitational pull is what keeps the planets, moons, asteroids, and comets in orbit around it. Nuclear fusion. The Sun generates energy through nuclear fusion in its core, where temperatures reach around 15 million degrees Celsius, 27 million degrees Fahrenheit. This process converts hydrogen into helium, releasing an enormous amount of energy. Sunspots. These are cooler, darker regions on the Sun's surface caused by magnetic activity. Sunspots can be larger than Earth and are often associated with solar flares and other magnetic disturbances. Solar wind. The Sun emits a continuous stream of charged particles known as the solar wind. This wind can affect space weather and create beautiful auroras on Earth when it interacts with our planet's magnetic field. Temperature variations. The temperature of the Sun varies significantly from its core to its outer layers. The surface temperature, or photosphere, is about 5,500 degrees Celsius, 9,932 degrees Fahrenheit, while the outermost layer, the corona, can reach temperatures of up to 2 million degrees Celsius, 3.6 million degrees Fahrenheit. Light travel time. It takes about 8 minutes and 20 seconds for light from the Sun to reach Earth. This means that we see the Sun as it was over 8 minutes ago. Solar flares and CMEs. Solar flares are sudden bursts of energy that can release as much power as billions of nuclear bombs. Coronal mass ejections, CMEs, are massive bubbles of solar material that are ejected into space and can impact Earth's magnetic field. Lifespan. The Sun is approximately 4.6 billion years old and is currently in its main sequence phase, where it steadily burns hydrogen into helium. It has enough fuel to continue this process for about another 5 billion years before evolving into a red giant and eventually becoming a white dwarf. Magnetic field. The Sun has a powerful magnetic field that extends far into space. This magnetic activity causes phenomena like sunspots, solar flares, and the 11-year solar cycle, where the frequency of sunspots and solar storms increases and decreases. Solar cycle. The Sun goes through an 11-year cycle of solar activity, including changes in the number of sunspots and the intensity of solar flares. We are currently in solar cycle 25, which started in December 2019. The Sun is not only the source of light and warmth, but also a dynamic and complex star with many fascinating features and processes. Its study continues to reveal new insights about our universe.